The way we code is changing, and so is the way we interact with our databases. If you find yourself burning up time, writing, debugging, and reading SQL, and have been curious about a better way to interact with your data using the latest and greatest AI technology, you found the video you've been looking for. This is the first video in a series where we build out our very own Postgres data analytics AI agent from scratch. Don't worry if you use a different database altogether. All the concepts you'll learn here are transferable to any SQL database. If you're subbed to the channel, you know that in nearly every video, we're pulling the future of programming into the present. Across this series, you'll see how you can push your engineering using AI tools and techniques. On this channel, we don't just talk about the new cool technology coming out. We build real, valuable, useful applications with them. I can guarantee if you stick around, you'll learn something new. Let's code our very own Postgres data analytics AI agent. Let's overview our tool set. We're going to use ChatGPT with GPT-4. We're going to use Neon, a serverless Postgres host, and we're going to use our favorite AI pair programming tool, Aider. Our tech stack is going to be a combination of Poetry and Python. Let's go ahead and initialize a brand new Poetry application. Open up VS Code. And here we have a plain Poetry application. Let's go ahead and create some structure. Let's create our scripts. Now let's go ahead and install some dependencies. OpenAI, install our Postgres driver, argparse to parse command line arguments, python.env to set up our environment variables. And we'll run Poetry install, generate a README. Awesome, let's create our environment file. Postgres database URL, I'm going to use a full URL string here. And then we want our OpenAI API key. I'm going to go ahead and set these. Set up a get ignore. And now let's make sure everything looks good by just printing something in our main. Awesome, fantastic. So now we have a basic Python application all set up and we are good to go. So what I'm going to do here is walk through the functionality that we want to run in our application. I'm going to fast forward to this part so we don't waste any of your time. Okay, so this is what we're going to do in this application. We're going to parse a prompt response where we're going to type in natural language, querying our Postgres database to give us a certain result, right? So let's go ahead and take a look at our table. I'm using Table Plus here, connected to my Postgres instance, and I've just got two simple tables, right? I've got a users table, which has an ID, created, updated, auth plan, name, email, and I've got a jobs table, which has also ID, created, updated, and then it has the parent user ID, which is a reference to the users table. And then I have a couple of statuses here and the total duration. So imagine some arbitrary system where you have users and your users run some type of job in your application. So we're going to connect to our Postgres database and get access to these tables. We're going to call a function that will have a couple of nested functions within it. This function is going to take our tables in our Postgres database and convert them into a readable format that the LLM can use to write SQL queries against. After that, we're going to add two references. Basically, we're going to add variables to our prompts to help our prompt be more accurate and concise. Then we're going to call the OpenAI endpoint and actually run our prompt. After that, we're going to parse our SQL response from the GPT response. And then finally, we're going to run that SQL we parse back on our Postgres database and get a full query back. So what we're going to end up with here is an application that we can use to type in natural language and get a response from our Postgres database. Normally, what we would do here is, start coding away. We would import argparse, get that rolling. We would build our database module. We would build our LLM prompt module. Just like I said in the beginning of this video, guys, we're not programming like we used to in 2020 anymore, in 2021 even. We're using the latest and greatest LLM technology to help us do our job for us, right? We're using this technology to get tons of value and to get a ton of our time back so we can focus on the critical aspects of writing software. So I'm not going to do any of that. What we are going to do though is prompt engineer our entire database module right now. So let's go ahead and create that file. I'm going to create a new folder called modules, and I'm going to go ahead and create our llm.py, and I'm going to create our db.py. We're going to prompt ChatGPT to generate our entire database module using this prompt. So here's the prompt. Create a Python class that enables objective. I need the following function support. And then you can see here I have a capitalized reference. If you've been watching the videos, you know exactly what these are. Ignore the spelling mistake. What we're going to do here is define functions that we need generated, but we're going to give a little bit of information, right? You can think of these as function prototypes. We're giving the LLM more information about what functions we want to see in our class. Okay, you can see here we have a couple different examples, plain a net function, a individual function here, a function with a parameter, and then a function here with some precise explanation of what exactly it does. I'm going to replace the objective template string, and we're going to say, create a Python class that enables us to operate on a Postgres database using our Python library, and I need the following function support for, I'm going to speed through this right here. Okay, so I have completed mocking out the functions for our Python class. Let's just walk through this so that it makes sense for when you generate your entire Python classes using this prompt. I'm just going to jump us back to plain text, right? Create a Python class that operates on a Postgres database using our library. I need the following function support, right? So I'm saying I need a init function, I need enter, I need exit. This allows us to use the with statement. We're looking for a connect with URL function. We're looking for an upsert. We're going to pass in a table name and then a dict. And here I'm using the dash and specifying some more information, right? So what does upsert do? It inserts or updates a row in the database if ID is present in the dictionary, right? So this is pretty cool. We also have delete, get all, and we have run SQL. Run SQL is going to let us run arbitrary SQL. This is what we're going to use after we get the response back from our LLM. We have get table definitions here. It's going to get a table definition in a create table format directly from Postgres as a string. This is what we're going to pass in to our LLM to build what is going to be our Postgres AI agent, right? This allows us to tell the LLM what our tables look like. Here we have a get all table names function, which is just going to give us all of our table names so that we can call get table definitions on it. And then in the last function, what we're going to do is combine get table definitions and get all table names to get a list of table definitions in a create table format for all tables in the database as a string. I want to clear up some of my language here. I said list and as a string. You want to be really clear and concise with your descriptions. You can reuse this prompt to basically generate any class you need to. So we're going to take our prompt fully filled out. I'm going to hop over to ChatGPT and let it rip. Fantastic. So as you can see here, it gave us an entire Python class that mocks out this functionality, right? So before, what was a entire situation of looking up documentation, typing the code by yourself is essentially all completely automated now, all completely abstracted away by GPT and a good prompt. I've been using this prompt for a while. I think you want to be like really storing these, reusing these. There's a lot of value here in creating these reusable structures that you can send to your favorite LLM, GPT-4, whatever it might be, to generate code, to generate text, to generate content for you. So let's go ahead, take this class. We're going to dump it in db.py, and we're just going to give it a skim here, look for any serious errors. This looks great. Let's go ahead and test out the connect with URL function. And let's go ahead and just run the get all statement. And just for those who are wondering, I'm using Table Plus. It's my favorite database UI for Mac. Let's import our Postgres manager. And now let's pull in our environment variables. I'm going to dump in the db URL from the .env file. I'm gonna call our get all function and pass in users here. And then we're just gonna print this out. Awesome. So as you can see here, these are the complete results from our users table as a list. So we can see here, we got john.doe outlook.com, hop over to table plus, go to the users table, we have john.doe outlook.com. All we did was construct a prompt, specify what our functions look like in an abstract, simple way, and then it generated this entire Python class for us, right? Now we can get rid of the example usage. Very likely there's some issues in here, but we're gonna work through them. The point is, likely in the worst case, we have 80% of a module, our Postgres database connectivity module completely done for us already. All right, so let's turn our attention to the LLM side of things. So we basically just need a way to run prompts, and we need an additional function to add capitalized references to our prompt so that we can attach our tables onto the prompt. So let's go ahead and just pull in something that I just keep reusing. I have this up as a gist. I found myself reusing this over and over again. I've taken one of my old prompts and reused it. Feel free to use this. I'm gonna go ahead and just copy this. As you can see here, all it essentially does is it has these two key functions here. We have prompt, and we have add cap ref, which I'll explain in a moment here. So I'm just gonna dump that in the LLM. Let's just give it a quick look here. And as you can see, we have the prompt function. We're just gonna make sure that we have the OpenAI key, just a little bit of safety, and then we're just calling check completion. We're defaulting to GPT-4, nothing special happening here. We do have this additional function though. We use capitalized references to add memory to our LLMs. And so this function just does that for us. We're gonna do some simple string concatenation, and you'll see the output of this as we proceed. And I'm going to import this entire module here. So just say import LLM. Now we have both of our modules set up. We have a connection to Postgres. Now we could, again, just continue coding piece by piece. We would get this done, right? We've already done a lot by generating the db.py file. We have our Postgres manager, but we can push this even further, right? I mentioned we're going to use my favorite programming assistant, Aider. So let's go ahead and break that open and see how Aider can help us accelerate our engineering. I'm going to throw a link up to my Aider video. If you haven't seen it, definitely that's going to be the place to get started. All right, so now I'm going to export my OpenAI API key, and now I'm going to type Aider. Awesome, so Aider's open. I'm going to add main, LLM, and db.py. Awesome. There are some text content in here, so I'm just going to take a look at the total tokens. We're at 2K. That's perfect. Here's where the magic happens. I've tabbed forward these comments. What we're going to do here is have Aider generate code based on our comments to the best of its ability. So let's go ahead and do that, right? So I'm going to say, read the comments, generate code based on the comment, read db.py and llm.py functionality you have available. Only update the main function. And let's fire off. So it's walking through step by step, reading the comments and generating individual steps for each comment. If you use Aider, you know that it spits out the previous version, then it starts generating the new code. All right, so let's see how it's done. The great part about Aider is that it runs a git commit, so you can always see the previous versions. Git log, you can see exactly what was changed. And even better, on the file that it's updated, you can simply hit Control-Z to see the previous version of your code. And then Control-Shift-Z, or whatever your redo keyboard shortcut is, to go backward, to undo the undo. And so as you can see here, it's using argparse. It did import argparse. I'm gonna go ahead and just bump that up to the top. That looks good. So we are gonna look for a prompt, and I'm going to get rid of our users table. It's just noise now. And now we have table definitions, get table definitions for prompt. This is really cool, right? It's actually looking at that add capref function we wrote, and it's filling it out. For instance, we could write a prompt, something like this, right? Show jobs that were created after September 5th, 2003, right? And if we hop back over to our table, we can see here, we have, a few jobs that were created after that date, right? So that's going to be what the prompt is. And now it's saying, here are the table definitions, and it's creating a capitalized reference, and it's going to then place the table definitions right after the table definitions capitalized reference. Don't worry if that doesn't make sense. It'll all make sense when you see the output. We'll have to make a little tweak here. Then we're going to prompt using llm.prompt, which is the exact right function name there, as you can see in the llm.py file. Then it's going to split the response, and then it's going to call db run SQL. So, I just want to take a moment to highlight that with the combination of Aider and ChatGPT, we have essentially generated 80% of the code needed to run this application. Now, I can almost guarantee you there are going to be some errors here that we're going to work through. But 80% of the work is done. Now it's time for you, the engineer, to dig in after you've used your technology, used the great LLM technology to, generate boilerplate. It's time for you to come in and verify, tweak, change, validate, right? So I'm going to do that right now. Let's add some print statements. Let's see what's going on. Let's clean up some of this code. Let's add some constants. So let's do that now. Okay, so after a little bit of code cleanup, we have a couple of print statements. We've filled out our capitalized references with some constants and more accurate prompt modifications. And at the end here, we're going to print out the prompt response. We're going to print out the parsed SQL query. And then at the end, we're going to print out our Postgres data analytics AI agent response. And that'll look like this. Okay. So there's a lot more for our agent to do and learn to do, but this is a really great start. Basically, from natural language, we'll be able to generate and run SQL. So let's go ahead and see where our application chokes. I'm going to run poetry, run start. All right, so we need to now specify a prompt. Same thing, but we're going to say prompt show jobs that were created after September 25th, 2023. This to be -- prompt. Let's go ahead and rerun. Local variable prompt reference before assignment. Let's go ahead and see where that's falling apart right here. I'm just going to say prompt equals args.prompt. Great. That doesn't need to be inside the with. Let's move that out. Run again. Cool. So it looks like we have an error from the ChatGPT generated code. So let's go ahead, dive into that and see what's going on there. What I'm going to do is copy the error verbatim just as is. I'm going to copy it with the entire command here and hop over to ChatGPT. We have an error. The code, here's the error. Again, we're using capitalized references. I'm going to dump the code there, and then I'll dump the error here. Awesome. So it's working through the error here. Looks like there is a change with Postgres version 12 and newer. Let's see if this updated version does the trick for us. I'm just going to go ahead and copy. I'm not going to worry too much about the exact details. I'm going to let GPT worry about that. I'm going to tab in here and just simply rerun our code. Okay, awesome. So looks like we got our table definitions here, and looks like it built the entire prompt for us. I'm going to go ahead and copy this. Here's what the entire prompt looks like right before we query OpenAI. So as you can see here, we have our prompt passed in, show jobs that were created after September. Then we have our capitalized references that were attached. So it says use these table definitions. And you can see here, there's the capitalized references to satisfy the database query. Okay. So we have the table definitions. Looks like they are getting successfully generated. And right after that, we have respond in this format. And then I specify the table format, and it's again, another capitalized reference. And we're going to reference this here. And it's basically, I'm specifying exactly how it should respond so that we can use this set of dashes as a delimiter to separate our SQL so we can easily parse it out. So let's jump back over to the code and see what's going on. Okay, so it looks like we had a parsing error. We tried to execute an invalid variable. So what we're going to do here is just clean up this prompt a little bit, right? As you can see, we got this kind of lingering functionality here. This isn't operating exactly as I wanted to. So let's go ahead and throw a couple new lines at this to see if we get a better result. So I'm going to say respond in this format. I need to be able to easily parse the SQL query from your response. So we're just gonna make a small tweak here and we're gonna rerun. All right, so looks like same problem. It's still leaving that text. Let's figure out what else we can do here. Is the text between open close with its request. I'm going to update this capitalized reference. I just wanted to say response format. Let's go ahead and tweak that. And then let's go ahead and rerun. Generating the right prompt to get consistent results is the trick here. It looks like this one got through. We have our Postgres Data Analytics AI agent response. And as you can see here, we have the individual rows. Looks like we have, 4 rows returned, which lines up with exactly what we would see from the response of that query. And if we dig into the SQL, you can see that we perfectly parse select star from jobs where created is greater than September 9th, 25th, 2023. And we order by created ascending, nice touch. And this is the first step to really creating our own analytics agent. So, a couple things to call out here. Definitely the trickiest part of this is getting the LLM to respond in a specific format. In future videos, we're going to experiment with ways to get the LLM to respond in a specific way so that we don't have to dance around exactly how we need our prompt to return. So we were able to build this out pretty quickly. There are definitely some startups and some companies building this out right now, but they're basically just doing this, right? This is one of the things that I want to show and kind of reveal on this channel is that you can build these tools all on your own. All the technology you need to do extraordinary things like this is here, right? Now, by typing in natural language, you can query your Postgres database. The queries and the databases, of course, are going to get a lot more complicated than just these 2 tables. But let me show you a couple more examples to show what else we can do with this. Users that are auth, that have had jobs running for longer than 3 seconds, right? So we have that auth variable here. We have 3 users auth, and then we have jobs here with a duration in ms, right? So these are in milliseconds. And I want everyone that's been running longer than 3 seconds. So let's go ahead and just fire off this prompt. Let's see what happens. Awesome. So as you can see here, we got back the rows we were expecting. Ideally, I'd want to get this back in key value form in a nice clean object. We can tweak that. This is just the first video in the series. We're getting up the basics. We're getting the scaffolding of our full agent in place. Let's push the prompt a little bit further that have a job with the status. Okay, so this is kind of tricky. With the completed statement, we should expect to see no jobs returned. We're looking for a count of 0 here. So let's see if it can pull this off. There it is. And if we highlight the statement here, we can look at exactly what was run. Across the series and across all the videos that I'm putting out right now, what I'm trying to do is build up your arsenal of tools and technology that you can use to build the application that you want to build. I hope you guys can see where this is going. We're building out our own Postgres analytics agent. We're giving it queries in natural language. In future videos, we're going to be building out our agent. We're going to be setting up APIs. We're going to be building out a nice clean user interface. And we're going to be making our agent run autonomously. You're not going to want to miss out on this. And throughout the series, once again, we're going to be building it using modern tech, modern techniques. Thanks for watching. Sub, like. I'll see you guys in the next video.